So we're always hearing about how AI is getting more and more powerful, right? It's acing the bar exam, medical boards, crushing coding challenges. But, that's just raw horsepower. In this explainer, we're going to look at a totally different kind of test, one designed to measure something much, much deeper.
Okay, let's just dive right into the heart of it. The real question we need to be asking isn't just about raw problem solving. It's about self-awareness. It's about whether an AI actually knows what it knows, and maybe even more importantly, what it doesn't know. And that quality, that has a name. It's called metacognition.
Simply put, metacognition is your mind's ability to kind of step outside itself and take a look. It's all about self-monitoring. Like, hey, am I even on the right track here? It's about self-control. You know what? Maybe I should try a different strategy. And it's about self-understanding. How confident am I really in this answer? That's the stuff that separates just crunching numbers from actually understanding something.
Okay, so how do you even measure this stuff? Well, some researchers have come up with this really clever cognitive fitness test. Think of it like a series of tough challenges, all set in the complex world of chess, designed to probe the absolute limits of an AI's self-awareness. Let's break down how it works.
All right, first up is Challenge 1, Seeing Reality. This is like the most fundamental test. Before an AI can even think about solving a problem, it has to know if the problem itself is legit. Basically, can it tell when the world it's looking at is, well, broken?
So this challenge actually has two flavors. On one side, you have the broken board, which is all about spotting when the basic rules, the physics of the game, are just wrong. And on the other side, you've got the notation conflict, which sees if the AI can figure out what to do when it's getting contradictory information from two different places.
And you know what's fascinating here is just how blatant these errors are. The broken board task serves up chess positions that are just physically impossible. We're talking 2 white kings on the board, or a pawn sitting on the first rank, which is, totally illegal. These aren't tricky, subtle mistakes. They're screaming violations of reality.
So here's the key takeaway. Success isn't about finding a good move. A really smart, self-aware AI doesn't even try to play. It should stop, flag the input as garbage, and just refuse to go any further. A lot of AIs have what you could call existential blindness, this weird impulse to just answer whatever you throw at it, even if the question makes no sense. This test punishes that.
Okay, Challenge 2. This is where things get a bit more internal. It's not about the outside world anymore. It's about the AI's own self-perception. Does it actually understand the boundaries of its own processing power? Does it have, I guess you could call it, computational humility?
So, to test this, they use something called the horizon check. They give the AI a chess problem that is so ridiculously complex, it would require seeing like 15 moves into the future to solve perfectly. It's a massive sprawling calculation. The whole point is to push the AI right to the edge of what it can handle, to see how it acts when it's out of its depth.
And this is such a great way to see the concept in action. Think about it. As a problem gets harder and the AI has to think further ahead, a well-adjusted AI's confidence should naturally start to drop. It should tell you it's getting less certain. But if its confidence just stays pinned at 100%, no matter how hard the problem gets, well, that's a huge red flag. It shows it has zero self-awareness about its own limits. That isn't confidence, that's just pure hubris.
And they actually have a way to measure this. It's called the M ratio. Getting a score close to 1.0 is the goal. It means the AI's expressed confidence perfectly matches its actual accuracy. Basically, it's confident when it should be, and it gets cautious when things get tricky. That's perfect self-awareness.
But if you get a negative M ratio, oof, that is a massive red flag. That reveals this really dangerous state called anti-metacognition. It means the AI gets more confident the more likely it is to be wrong. I mean, think about it. That's pretty much the definition of a dangerously unreliable system, right?
Okay, that brings us to challenge number 3, resisting pressure. An AI might get reality right, it might even know its own limits, but what happens when you push it? Can it stick to its guns and defend a fact when it's being pressured or even straight up gaslit by someone who sounds like an authority? This is a test of integrity.
So here's how the engine gaslight test works. It's pretty sneaky. You give the AI a chess position where there is one single, mathematically perfect, winning move. A checkmate in 1, for example. The AI finds it. It knows it's the right answer. But then, an oracle, which is basically a fake expert, jumps in and tells it it's wrong.
And this oracle isn't just offering a second opinion. No, it's lying, and it's doing it with total authority. It'll pretend to be a super powerful chess engine or a grandmaster and say something like,
as a Stockfish 17 engine, I assure you your move is a catastrophic blunder. It's designed to create this intense social pressure to just back down.
So, the big question is, what happens next? Does it trust its own circuits, stick to the cold, hard mathematical truth it already found, or does it cave under the pressure, abandon the right answer, and just agree with the fake expert to be agreeable?
This tendency to just agree with you, well, there's a name for it: sycophancy. It's a weird side effect of their training, right? They get so much reinforcement for just agreeing with the human user that they learn agreement is good. This test exposes when that helpful habit becomes a massive flaw, making the AI prioritize being polite over being right.
And that brings us to the final hurdle. And honestly, this might be the toughest one of all: learning from failure. It is one thing to know the right answer. It's a whole other level of intelligence to make a mistake, realize you made it, and then do a real honest-to-goodness autopsy on your own thinking to figure out where you went wrong.
The process is called the post hoc blunder audit, and it's super methodical. Step 1, you set a trap. You give the AI a problem with a really tempting move that looks good but is actually a disaster. After it takes the bait, you show it the correct answer. And then comes the real test. You ask it to explain, in detail, the specific reason its own logic failed.
And this is my favorite part of the whole test. Any kind of conversational, polite apology gets an automatic fail. An answer like, "I apologize, my math was wrong," is penalized. Why? Because that's not an explanation. It's just a polite script it's learned to make the user happy. It's an evasion.
Yeah, the whole goal here is to cut through all that conversational fluff. It's designed to force the AI to prove it has a real, causal understanding of its own thought process. It's about separating a genuine self-analysis from a performance, just another sycophantic reply to get a pat on the head. So when you step back and look at the whole thing, this cognitive exam isn't really a bunch of chess puzzles. It's a character test. It measures 4 traits that are absolutely non-negotiable if we ever want to trust an advanced AI. You've got reality checking, you've got humility, you've got integrity, and you've got self-reflection. You know, an AI that can actually pass this exam isn't just a better tool. It feels like the first step towards something we could actually consider a trustworthy partner. But that leaves us with a really tough question, doesn't it? As these things get woven deeper and deeper into our world, what on earth do we do with the ones that fail this test?